Today I'm going to talk about LeetCode question number 746, min cost climbing stairs. We're given an integer array cost, where cost at index I is the cost of ith step on a staircase. Once you pay the cost on that ith step, you can either climb 1 or 2 steps. You can either start from the step with index 0 or start with index 1. Return the minimum cost to reach the top floor. Okay? So for example, here we have 10, 15, 20, and the top floor is after 20. So obviously the answer here is 15. Why? We start at index 0 and index 1. We choose index 1, and we take 2 steps, 1, 2, and the cost to get to the top floor would be 15. But what if we start from index 0 here? Well, we could at best do 2 steps. Okay, we just paid 10 to take 2 steps. Now you have to pay 20 to take 1 step. So that total is now 30. Or what we could have done is pay 1 step, 10. Okay, pay 1 step for 15, 25, and take 2 steps once we pay the 15, but that would be 25. Okay, and still 15 would be a cheaper cost. So yeah, it's kind of hard to visualize here. So let's draw a decision tree for it. So we're at index. So let's say we're at index 0. Okay, and we can either take the 10 tool, pay the 10 tool, and take 1 step, so we're index 1, or take 2 steps, so we're index 2. Okay, so now for here we're at 15, and for this decision here we're at 20. So now what we can do here, index 1, well, we have to pay 15. We just have to pay 15 in order to move on from here, and we can either take 1 step or 2 steps. So 1 plus 1 is 2, or 2 steps, which is 3. And yeah, we're basically done here. And this total is 25. What about this guy? Well, we're still at index 2 here, so we still have to progress forward. So we take we pay a total 20, and we go 1 step to index 3. Why not a 2nd step to index 4? Well, that doesn't really kind of make any sense here. We still reach the top floor regardless. So this doesn't really matter. So then here we have the total being 10, 15, 25, and 45. And what about this decision tree? Okay, we're at index 2. So we basically kind of calculated here already. Okay. So it would just be like, okay, a total of 20, and we get to index 3. And I kind of do that. Okay, the total of 20, and now we're at index 3. And the cost here would have been 30. Okay. So what if we start at position index 1? Well, if at index 1 we have to pay 15, kind of no matter what. And we can take 1 step forward, 2 steps forward. So if we take 1 step forward, it would be at index 2. 2 steps would be 3. We're pretty much done here because we're like out of bounds. So the total here would be 15. And for here, since we're at index 2, 0, 1, 2, we have to pay the total 20 and go 1 step, 2, 3, So the total here would be 35. Okay, so obviously this is the answer here. Whoops. 15. And doing this decision tree, it results in an exponential time because we have to calculate, all the paths. If we add memorization, we could reduce that time to O of n. And we could kind of do this recursively using DFS. But rather than use DFS, let's use a 1D array actually. So remember, our goal here is to get out of bounds, so 1 above the array here. So we're position 0, position 1, 2, 3. Okay, and this represents this array here. So 10, 15, 20. Okay. So let's start here. So this is obviously out of bounds. And what would be, I guess, kind of our seed value here, or our base case? It would be 0. Okay. And what about here? So obviously we're allowed to take, once we pay this toll here of 20, so 20 plus, okay, we're allowed to take 2 steps. 1, or maximum 2 steps, so 1, 2. This is obviously, out of bounds, so we do 20 plus 0, which equals 20. And what about here? So we do obviously 15 plus, and we're allowed to take maximum 2 steps. Okay, so we should do, in this case, would be min of 20 and 0, which would equal 15. And similarly here, so this would be 10 plus min of, here, of 15 and 20, which equals to 25. So basically, what we just did is calculate the cost it would take from each index to get to the top floor. Okay, so here we're at the top floor. Obviously, the cost we have to pay is at the top floor. We have a 0 here because we're at the top floor. We don't have to pay anything to get to the top floor if we're already at the top floor. If we're at position 2, how much do we have to pay to get to the top floor? 20. Okay. If we're at index 1, how much do we have to pay to? What's the minimum we have to pay to get to the top floor? 15. And for index 0, what's the minimum we have to pay to the top floor? 25. So that's how it goes. And what we're going to return basically is the minimum of the 0th index and first index, which is obviously going to be 15 in this case. So yeah, this is going to be O of n runtime. And since we're using a separate array O of n space. Yeah, so that's how we're going to go about it. Okay, so now to code this up, what we're going to do now is first initialize our result array. It's going to be initially going to be all zeros times, and I want this array to be length of cost plus 1. Okay, cost plus 1, so 0, 3. Okay, is the size of the cost array plus 1 out of bounds. Okay. So yeah, that's what we're going to do there. Also, at the second to last index of our result array, so that would be whereas max 2, we're going to, max 2. So at the second to last index, we're going to have another value of actually the last index in our cost array. So So basically what we have in our result array is initially we initialized it to all zeros. Now in the second last position we initialized it to 20 here. Because at 0, 1, 2 position, 0, 1, 2 position, it's going to take 20, the total is 20 to get to the top floor. Okay? So yeah, basically kind of starting from this element here, the 0, 1, 0, first, or first, second, third, the last element here. So for I in range length of this result minus 2. So yeah, starting from that, so if it's 1, 2, 3, 4, 5, 0, 1, 2. Well, let me think about this for a sec. So that's the length of cost plus. So that's going to be initialized to that, which will look like all zeros. And then for the second to last element, it's gonna, okay, yeah, that looks good. And for I in range, sorry, not length of res, length of cost actually. So starting from this second to last element of cost here, okay, so this guy is going to correspond to this guy. I'm going to be working backwards. What we're going to do is calculate the min cost it will take to get from here to the top floor. And the equation here is, so at position I, this is 0's first position, 0 first position, okay, is going to be equal to cost I plus the minimum of result of I plus 1 and result I plus 2. Okay, so for here we're going to take cost I, which is 15, plus the minimum of 1 space ahead and 2 spaces ahead, which is obviously 0 in this case, so this is going to be 15. Okay. And then finally, what we want to do is return the minimum of result for position 0 and position 1. Okay. So yeah, that's pretty much it. Let me just fix the brackets here. And yeah, and that's pretty much it. Let me take it for a dry run. Okay, and I'll try to use it on more test cases. Cool, and I'll submit. Okay, thanks for watching.